Recording in progress.
Yeah, comes on everyone. Let's start off. Great. The last thing that we did was this particle on an incline. Let's go ahead with a few more problems. The next thing is the two block problems. These are one of the most important things. Others do keep your cams on. Let's start off with something easy and then we'll slowly build upon this. So we have two blocks here, 3 kg, 2 kg. The floor is smooth. The friction between them is 0.2. And you're applying a force F is equal to 4 newtons. Find the acceleration of the blocks. There. Ground is smooth, right? God, why won't it move? There's nothing stopping you from moving. Right, Arna. But let's see the process. So listen to the process. So the first thing, right? The most common mistake is this. This is what people do. Step one, draw the free body diagram. They do this. 2 kg. Force is 4 newtons. Then we write F max here, which is mu into N, which is 0.2 into 20, which is also 4 newtons. Three kg. This is F max, which is 4. Now, when you do this, you will realize this guy acceleration is 0, and this guy is going on acceleration 4/3. So be careful with this. This is a blunder. You can't do this. Why? The first problem is this. Who told you friction is maximum? You get nothing there. When do you take friction is maximum? When you're sure the blocks are slipping. If you're 100% sure the blocks are slipping, then you can take F is maximum. So we don't know whether the blocks are slipping or not. And look at the absurdity of this thing. You're applying force F on the top block. That block is not moving, but the block at the bottom is moving. Meaning, imagine you kept a water bottle on a dining table. You're pulling the water bottle. That doesn't come, but the dining table below is coming towards you. Doesn't that look scary? That means there's a ghost in the house. Kidding it. So the block you're pulling, that is not moving. The table below it is moving. So we don't know. So the problem is this. We don't know whether the blocks are slipping or not. We can't take F maximum. That is a problem with these two blocks and whatever, right? We don't know whether the blocks are slipping. So therefore, we can't take F max. So remember this process. The moment you see 2 blocks or 3 blocks, you always start like this. We start with an assumption. What is the assumption? Let them go together. Let's see what happens. Assume the blocks go together. Now, if you're assuming both are going together, three kg, 2 kg, acceleration is A is equal to 4/5. Perfect. Then take any one block. I will take the 2 kg block. Let the force be F and let the friction be small f. I don't know the value of friction here. And the acceleration A is equal to 4/5. So F minus friction is equal to 2 into acceleration. So F4 newtons friction, this will be 2 into 4/5. So here we get friction is equal to 12/5 newtons, which is 2.4. Now remember this, what we got here, listen carefully. What we got here, see, I didn't use mu ka value anywhere. I didn't use mu into n anywhere, and I got a friction ka value. This is the friction's way of saying, boss, I need this much friction. So the friction is saying, this is the required friction. Friction is saying, you give me 2.4 newtons, and I'll make sure your assumption is right. What is my assumption? The blocks are going together. You're getting the meaning of interpretation. The friction is saying, if you want the blocks to go together, I need a value of 2.4. So this is called required friction. If we give 2.4 newtons, blocks go together. That's the assumption. Great. What is F max? And we know, so this F requirement, which is 2.4, is less than F max because maximum is 4 newtons. So my assumption is right. You're asking for 2.4 and I can give you 4 newtons. So therefore, the assumption is right. What was my assumption? They're going together. That's it. Question gets over here. So the answer is acceleration is 4/5. And what is the friction between them? 2.4 newtons. It is not 4 newtons. Is the process clear, everyone, what we did? Getting it? This is how you start a 2-block problem. Like, because in a 2-block, the biggest headache you have is we don't know whether they're slipping or they're going together. And without being clear about that, if you just put F max everywhere, sometimes you'll be lucky, sometimes you'll get slaughtered. So when you see 2 blocks, this is how you start. You start with a thing, assume they're going together and see what happens. Let's see the other case. What would happen if the assumption fails? So let me give an example of that also. Same question, I'll take the same numbers. So in the previous question, they can ask you what is the friction between the blocks. It is not 4 newtons. Remember, like I said, I can give you 4, but do you need 4? You need only 2.4. So let's say 20 newtons I'm applying. Same story. Mu is 0.2. So same story. Assume both are going together. Then acceleration will be 20/5. 4 meter per second square. Choose any one block. I'll choose the 3 kg block. You can choose any one actually. The friction on the 3 kg block will be forward. So always write it as F. Don't write F max. So we get F is equal to 3A, which is 12 newtons. So this is the required friction. Friction is saying, you give me 12 newtons, I'll make sure the blocks will go together. But we know the maximum you can give is 0.2 into 20 is 4 newtons. So therefore, my assumption is wrong. Okay, fine. What is my assumption? They are going together. So that means now they're not doing it. That is fine, right? That means, so therefore it is slipping. My assumption is wrong. So this implies they are slipping. And if they're slipping, then the friction must be maximum. So therefore F is max. So there, if my assumption is wrong, I know now f is maximum, then draw the separate FBDs. So you have to draw the FBDs again. F is equal to 20. Now you can write F max because now you proved it. This is the acceleration A1. So this A1 will be 20 minus 4, 8 meter per second square. This is 4, and let's say this acceleration is A2. A2 is 4 by 3. So this is what will happen, everyone. There are only two possibilities you can get. Either they're going together or they're slipping. If they're going together, my problem will end there, and that's your answer. F required is F, and you got the acceleration. If their assumption is wrong, that is also okay with me, because now you proved F is maximum. I will draw the new FBD. So whatever you have done, everything you just cancel it off, and then again start fresh. Draw a new FBD with the F maximum and finish it off. That's it. There's no third way, right? Either your assumption is right or it is gone. Either way, you'll get an answer. Is this process clear? The reason we have to do this is because I don't know before starting the question whether they're going together or not. Got this? Let's see one more like this. Now you try. I'll keep it simple for now, then slowly add things here. Let's say we are adding F is equal to 15. Three kg to let it be F. Let's say mu is equal to 0.5. And the first question, if F is equal to 25 newtons, find the acceleration and the friction between them. Second thing, find the maximum F so that the blocks don't slip. So what is the maximum force you can apply so that the blocks don't slip? Let's make this 20 newtons, huh? 20 newtons. There, give it a try. Two different questions. These are another set of problems, the two blocks. Biggest confusion is that only. Every time people just put F max and finish it out. Don't do that. You don't know because you can't write F max. That is the whole story of the chapter actually. You don't know when F is maximum, you don't know the direction. Let's see. So let's start with that. So 4, 8, I think, yeah, people are getting it. 4, 8, I think, right, right, Ahana. Okay. So Same story. You see two blocks, always start with that. Assume they're going together. That way you won't do a mistake because what happens, right? In exam, the flow, you'll put F max and you'll start. So always keep your process simple and repetitive. Then if something changes in the problem or something new comes, then you'll understand where to adjust. So acceleration, then yeah, this is 20. We are doing the first case. Acceleration will be 20 by 5, 4 meter per second square. Choose any one. I'll take the 2 kg guy. You can take any one. The friction must be forward for this one. Acceleration, so F is equal to 2a, that is 8 newtons. This is your required friction. Friction is saying, give me 8 newtons. I'll make sure they'll go together. How much can I give? Mu into n. That's 0.5 into 20 newtons. So that is 10 newtons. So yeah, my assumption is right. So therefore, my acceleration is 4 and the friction is 8. Done. The question gets over at this instant. I hope the logic is making sense. So I can give you 10, but it doesn't mean I'll give you 10. I'll give you only how much ever is required because my job was to make sure you both go together. My job was never to stop you. So that is the thing. F will not be maximum. You give only what is the requirement. And how do you know what is the requirement? So this is the way to figure it out. For the second part, now you're saying what is the F maximum so that they go together. That means in this scenario, right, the friction has reached maximum value. So you're asking for F max, now the blocks are about to slip. So this is actually easy. So the blocks are about to slip, meaning F is maximum. So we have acceleration is F by 5. Take any one block. Now this friction must be F max, which is 10 newtons, and this is acceleration. So 10 is equal to 2 into A. So A is equal to 5, which is F by 5, and then this is F max is 25. And there. So if you apply 25 newtons, you're on the verge of slipping. Anything more than 25, they'll start skidding. Got this? So that's how you approach this thing. These are basic problems. This is how they'll frame at a mains or a bits level questions, two blocks. Now, if I take it a little step forward, it'll be even better. They can plot graphs, but everyone clear with the two blocks. These are all the possibilities. Either you're not slipping, you're slipping, or you're on the verge of slipping. These are the only three cases you have. Let's say the same question. Let's take the two blocks, 3 kg, 2 kg. Let's say this mu is 0.3. Now you're applying a force F equal to time. These are beta questions. So the force is not constant, it is increasing with time. So the advantage of these questions, right, is this. Because you're increasing the time, you have all the possibilities. For some time, they'll go together. For some time, they'll slip. After a certain time, they'll slip. So plot acceleration versus time graph. If the force is continuously increasing with time, plot acceleration of 2 kg and 3 kg versus time graph. Get this. So we will take this as a base problem and we'll keep adding things to this. Let's get the graph. Yeah, that's how it looks, but try to get all the data, get the slope of those lines and everything. Think for a minute, I'll show you one and then we will add more to this. Let me show you one. So same story. Step one, assume both are going together. We start like that only. Acceleration is a. So we get acceleration is equal to f by 5, which is t by 5. So your acceleration is not constant, increasing with time. Take any one block. I will take the 2 kg block. The friction will be forward, and this is the acceleration. We get f is equal to 2a, which is 2t by 5. Remember, this is the required friction. Meaning, if you look at the requirement here, the requirement is not constant. When t is 0, friction is 0. When t is 1, friction is 2 by 5. When t is 5, friction is 2 newtons. So as time is increasing, you're asking for more and more from the friction. So F required is 2t by 5. And we have to make sure this cannot exceed the maximum value, F max. And what is the F max here? F max is 0.3 into 20, that is 6. So that is 2t by 5 is less than equal to 6 newtons. So we get t less than equal to 15 seconds. What is the meaning of this? The friction is saying up to 15 seconds, I can provide you enough so that you don't slip. You're getting the meaning of it? That is how you read it. So that means up to 15 seconds. The friction is saying, boss, I have enough value so that I can keep together. So up to 15 seconds, blocks go together. That is great. That means it is clear. So for t greater than 15, they're going to slip. And if the blocks slip, then you know what happens. F is maximum. So you just draw the new free body diagrams. So this will be F max, which is 6 newtons. And this would be acceleration. How much? 6 by 2, 3 meter per second square. For 3 kg, this would be F max, which is 6 backward. And this is F is equal to T. This will be T minus 6 is equal to 3A2. So we get A2 is equal to T by 3 minus 2. So look at these values. So this was the acceleration. This was the acceleration. This was the acceleration. So we want to plot a graph for this. So this is how the graph will look like. I am plotting both on the same graph. So initially, the acceleration is t by 5. So it will be a line like this. So acceleration is t by 5. We can clearly see this is looking like y is equal to mx. So this angle will be theta, which is tan inverse 1 by 5. That is the angle. And then this becomes constant. How much? 3 meters per second square. This is the acceleration of the 2 kg block. The other guy, you'll have the same acceleration drawing the green line. At this point, this is your 15 seconds. At this point, the graph will become like this. And look at the acceleration here, t by 3 minus 2. This is not a line passing through the origin. Y is equal to mx plus 3. So the slope has become more steep, tan inverse 1 by 3. This is the acceleration of the 3 kg block. And this is how the graph looks. So the graph looks identical up to 15 seconds and then the split. and these other slopes, it will become more steep after 15 seconds. Is this clear, everyone, how to draw the graph? For t less than 15 and t greater than 15. So this is a graph for t less than 15. All clear? Now, same question. Let's push it a little more. Now I'll keep the numbers same. Let's say this is 2 kg. 3 kg. Let's say this F is equal to T. Let's say this mu S is equal to 0.2. Mu K is 0.1 there. Now I'm bringing mu S and mu K. And let's say this mu S is 0.3. And let's say this mu K is 0.1. Great. Same thing. Plot A versus T graph. This is a good one. Now there is a friction on the ground also. There is a mu S, mu K also. Everything is there. Let's see how will you approach this. Give it a try. Plot AT graph for this. Slightly more complex this is. So first of all, think of like this. How many different ways these things can move? For some time they won't move. Do you agree? Until unless you break the friction on the ground, you're not going to move. So that is the first possibility. They're not going to move for some time. Then they'll go together for some time. Then they will slip. So there are total 3 different cases. So first you need to figure out up to what time they won't move. Yeah, so that is like the friction on the ground is 10 newtons. Up to 10 newtons, nothing is going to move. Up to 10 seconds. Then what? From there, try to build it up. Try. I'll give another 2-3 minutes, then I'll show. The graph is like a little weird. And you have mu K also. The moment you slip, friction ka value suddenly changes. So this thing, I messed up multiple things. Into 20, they move together. Yeah, that's there. But when you draw the graph, you'll see something weird. Yeah, they move separately, but how? Let's see. Okay, let's see the starting part. So F max on the ground. So it's 0.2 into 5, 10 newtons. Right. So until unless you break this, you're not going to move. So up to 10 seconds, system is at rest. Great, that was clear. Now for t greater than 10 seconds, both the blocks, again, now we don't know actually what can happen. So we will start an assumption, let both the blocks go together. So again, you go back to the process. You start with an assumption they are going together. Now when you draw the free body diagram, see how it looks. This is F is equal to T. This is where you have to be careful. Now since it is slipping, the friction is Fk. It is not Fs anymore. And the value will be 0.1 into 50. It is 5 newtons. So that is the thing. The moment it is going to slip, the friction values will change. So this will be t minus 5 is equal to 5 into acceleration. We get acceleration is t by 5 minus 1. Then take any one block. I will take the 2 kg block. Remember, the story is still not over. We need to find the friction between them. The only reason why the 2 kg is moving is because the friction between the blocks. I will call it F. And remember, this friction is F static because you're not slipping, right? You're assuming they're going together. A. So F static will be 2 into A, and this should be less than equal to 0.3 into 20. So this would be 2 into t by 5 minus 1 is less than equal to 6. That would be 3, 4. We get t less than equal to 20 seconds. Meaning up to 20 seconds. So the friction is saying, boss, up to 20 seconds, I can keep this together. You're getting how the interpretation goes? So that is the second part of the problem. So 10 seconds, they'll start going together, and 10 to 20, they are up to 10 seconds, no one is moving, and 10 to 20, they're going together. And for t greater than 20, now the blocks will slip. The friction gives up and says, boss, this is the maximum I can give. If you're slipping, then the friction becomes kinetic. This becomes 2 kg, and this becomes F kinetic, which is how much? K became 0.1 into 20, which is 2 newtons. And this is the acceleration, 1 meter per second square. So that is the thing you have to be careful, nothing much. Every time you figure out it is slipping, the friction value will change. This is F is equal to T, and this becomes Fk, which is 2 newtons. This becomes Fk ground, 5 newtons. We get A2 will be T minus 7 by 3. Those are all your accelerations. Now, if I just put all the accelerations, acceleration for the 2 kg block, so initially what was acceleration? 0, then t by 5 minus 1. So 0 for t less than 10 seconds. T by 5 minus 1 for t between 20 to 10. Then it is a 1 for t greater than 20. Acceleration of 3 kg block, 0 for t less than 10. T by minus 1 for t between 20 and 10. And it is t by 3 minus 7 by 3 for t greater than 20. Now, when you plot the graph, so for the 2 kg, the graph will look like this. So for 10 seconds, it will be 0. and something happens here. See, if I put t is equal to 10 here, the value will be suddenly 10 by 5, a is equal to 1. It's not 0. So this graph will suddenly jump from here to here. It's a discontinuity there, and then it goes like a straight line till 20 seconds. So this is 1. If I put t is equal to 20, a will be 3. And this guy ka value will go from 1 to 3. And then the value suddenly drops to 1 again. This is how the graph looks. Check. And this angle will be tan inverse 1 by 5. This is the acceleration of the 2 kg block. It is 0 for 10 seconds, that it will increase from 1 to 3. So there is a jump, it's a discontinuity. And then suddenly it drops back to 1 and then becomes constant. The same way, if I draw for 3 kg, this will be also same. It will follow the same story till here. Here, see, if I put t is equal to 20, this acceleration will be 20 minus 7 by 3, that is 13 by 3. If I put t is equal to 20 here, that you can clearly see is 3. 13 by 3 is definitely greater than 3 ka value. So the graph will jump from here. Again, you get a discontinuity. So every time you slip, there's a discontinuity. And the graph becomes even more steep. This will be tan inverse 1 by 3. I should have kept it less steep actually, but okay. This is how the graph looks. This is the acceleration for the 3 kg. So there'll be two discontinuities here and here. You can see the graph is not continuous because the value suddenly goes from f max to suddenly fk max. So it just drops. Is the graph clear, everyone? So if you have mu k in the question, then there'll be discontinuities in the graph. That's the catch in the questions. Everyone clear about this? Let's see one more. Let's say we have two forces now, F1, which is 3 into time. Let's say F2 is equal to time. So you're applying two forces. Let's say this is 3 kg and this is 2 kg. And let's say the floor is smooth. This friction here, mu s is 0.5 and mu k is 0.1. Plot AT graph. You can have two forces which are changing with time. Again, remember the process is the same. One thing is clear: since the ground is smooth, they have to move. There is no way they can remain at rest. So you only get two possibilities. They're going together for some time and they're slipping. Let's see how do you do this. How do we do this? Try. Take 2-3 minutes more. It's like I said, they're not difficult. They're just lengthy graphs. You have to just keep drawing them. Okay, let's see. I don't know the answer. I have to check. I don't think you'll get good numbers, but let's see. They'll go together, so we'll start with this. Let them assume they're going together. So this will be 3t minus t is equal to 5a. There's no other force, so acceleration will be 2t by 5. Then take any one block. I will take the 2 kg block. This would be 3t. This would be friction. This would be acceleration. So this will be 3t minus friction is equal to 2 into a. That will be 40 by 5. So we get friction is equal to 4 by 3, 15, 11t by 5. Yeah, numbers are not great. And this should be less than equal to, what is the maximum friction between them? This is static, okay? That's 0.5 into 20. That would be 10. So t will be less than equal to 50 by 11. Check. That's, I think, around 4 point something. So it's up to 50 by 11, they'll go together. That's what it is trying to say. Any doubts still here? So my assumption is right up to 50 by 11. After 50 by 11, and if you see it is the same process every time. For t greater than 50 by 11, the blocks will slip. If the blocks slip, two kg, this will be F1 is equal to 3t. Now this friction becomes Fk, which is 0.1 into 20, which is 2 newtons. This will have a different acceleration. This friction will be Fk is equal to, this will be a different acceleration. This will start going backward with A2. So we get A1 is equal to 3t minus 2 by 2. 3t by 2 minus 1. And this acceleration will be t minus 2 by 3 minus I cap. The direction has changed, so be careful with that. Yeah, you're done. So if you try to plot the graph, so initially they will go together with this acceleration 2t by 5. And then look at A1, what happened. Suddenly, when you put 50 by 11 here, yeah, numbers are not really great. So if I put 50 by, so if I put 50 by 11 here, how much will I get? 2 into 50 by 11 by 5, 5, 10, 20 by 11. So you will reach till 20 by 11. If I substitute 50 by 11 here, so that would be 3 by 2, 50 by 11, 2s are 25, 75 by 11 minus 1, 64 by 11. This value will suddenly jump to 64 by 11. There's a discontinuity. And then the graph becomes like this. This is for the 2 kg block. This angle will be tan inverse 2 by 5. This angle will be tan inverse 3 by 2. It becomes more steep. The other guy is even interesting. You will have the same acceleration, and then suddenly, see, look at here. If I put 50 by 11 here, you will suddenly drop into the negative zone. You actually become negative, and then you become like this. This graph actually becomes negative. This is the acceleration of the 3 kg block. Clear with this? Because the direction has changed, the sign also will matter. All clear with this? I hope you're able to get the 2 block problems now. So 2 blocks, they can play like this, like you got the process. The first thing you need to check whether, see, there are only 3 possibilities. Either they're not moving, or they're going together, or they're slipping. इसके अलावा और कुछ है? That's it. These are the only 3 possibilities you have. If the ground is smooth, there is no way both will be at rest. They have to move. So if the ground there is a friction, then there is a possibility they'll not move for some time. And this is how you start the problems every time. Assume they go together, find the F required, then see the acceleration, and then finish it off. Any doubts on this? So technically we have in the portion up to 2 blocks, but we will still see some 3 block problems. So how will you handle the 3 blocks? We will just see 1 or 2 models just in case. And with that, we'll finish all the friction today. We'll start off with circular motion introduction. So let's say we have 3 blocks. I'll keep the floor smooth. This is 5 kg. This is 3 kg. This is 2 kg. And let's say you're applying a force. F is equal to T. So a force is changing with time. This point here, mu is 0.2. Here mu is 0.1. We'll not drink mu case here, it'll become more messed up. Same story, plot 80 graphs. Let's say how will you handle a 3 block problem? Think. How will you handle this thing? The story is still the same. You still have to follow the process. But the headache here is the friction between 2 and 3 does not know anything about friction between 3 and 5. So both the frictions will think the other guy doesn't exist. That creates a little issue there. Take a minute. Let's see if you can figure that out. Then I'll show you. Then we'll do one more like this. Then you'll be clear about it. Okay, let's see. We start the story the same way. I don't know what is happening with all of them, so assume all are going together. Now here there are three possibilities. They're all going together. Two blocks are going together. All three are slipping. So that's the three options you have. We'll start with assume all go together. So in these kind of problems, right, if following the process is important because there are a lot of things that you can change and you know the process, then you understand where to adjust it. So acceleration will be t by 10. Perfect. Then let's talk about the two cases now. The first thing, I'll take the 2 kg block. So on the 2 kg block, the friction will be F1 and this was your acceleration. So F1 is equal to 2a and this must be less than equal to 0.1 into 20. And so this is the t by 5 is less than equal to 2 seconds. So t is less than equal to 10 seconds. So F1 is saying, boss, up to 10 seconds, I can make sure 2 and 3 are going together. Understand this. F1 does not know what is happening between 3 and 5. So F1 is saying, right, up to 10 seconds, 2 kg and 3 kg go together. That is what it is saying. We still don't know whether it is true. Great. Now let's ask the other guy. So I'll take the 5 kg block. You can actually take anything. F is equal to t, and this section will be F2, and this is your acceleration. And this would be t minus F2 is equal to 5a. We get F2 is equal to t by 2. They should be less than equal to, F2 will be 0.2 into this full normal reaction, which is 50. That would be t is less than equal to 20 seconds. 20 seconds is saying, I can make sure 3 and 5 are going together for 20 seconds. There is a problem here. Look at what we did. You got this acceleration t by 10 under the assumption all were going together. Agreed? You got the Eka value t by 10 under the assumption all are going together. But F1 is saying after 10 seconds, I can't help you anymore. That means the blocks started slipping at 10th second only. So this is wrong actually. This data is wrong because at 10 seconds, the blocks already started slipping. So you got 20 seconds under the assumption that 2 and 3 kg are still going together. So you should take the minimum time. So this is wrong. There is no way out here. You have to do for both of them and see who is the minimum time. So we take the minimum time. So we take the least time because we calculated each one of them under the assumption the other guy is not slipping. So because we calculated F2, under the assumption 2 and 3 are going together. So this is the problem when you have multiple blocks, they get the answers without figuring out what the other guy is doing. under the assumption 2 kg and 3 kg are going together. So F2 is wrong. So at 10 seconds, the therefore part B is wrong. So at t is equal to 10 seconds, 2 kg, 3 kg slipped. There. It's like this. Mom brought two, pastries for you and kept it in the fridge. One for you and one for your younger sibling. You're in a class and you're under the assumption I'll go home and I'll eat my pastry. Under the assumption, both the pastries exist. Right? By the time you reach home, your younger sibling has eaten both of them. Ever happened? And there's a big fight going on. So kind of like this. So F2, right, got the value 20 under the assumption F1 is there. But anyway, we figured out something. So up to 10 seconds, they all are going together. So we take the least time and then we will say for t less than 10 seconds, all are going together. This is okay. So if it is a 4-block problem, then you have to do it for 3 things. Then you have to check the time for everything. So for t greater than 10 seconds, what happened? At t greater than 10 seconds, 2 kg started slipping. 2 kg and 3 kg slip. Okay, that means at least 2 kg ka the value we figured it out. So for 10 seconds, 2 kg, this guy F1 has become maximum, which is 2. This is the acceleration. So we get acceleration of 2 kg will be 2 by 2, 1 meter per second square. Perfect. Now, the remaining 2 guys, again we start the story. Assume 3 kg and 5 kg go together. So you convert a 3-block into a 2-block problem. Now when you draw the FBD, this is the 5 kg, this is the 3 kg. Remember, this friction is maximum F1 max, which is 2, and this is F is equal to T, acceleration. We get T minus 2 is equal to 8A. So we get acceleration is T by 8 minus 1 by 4. Take any one block, I'll take the 3 kg block. This friction will be F2, this will be F1 max. Length, if you see it is just brute force, you're just solving. So F2 minus 2 is equal to 3 into acceleration. So we get F2 is equal to 3A, which is 3T by 8 minus 3 by 4 plus 2. And this guy must be less than equal to 0.2 into 3. 0.3 into 5, 10 newtons. This would be 10 plus 2, 8. 8 plus 3 by 4, 8, 4, 32, 32, 35 by 4, 2, I'm getting 70 by 3. So T will be less than equal to 70 by 3. If you look at this number, right, is roughly 23.33 seconds. Did you notice something? This gave you 20 seconds, which was wrong actually. The slipping didn't start at 20. The slipping started at 23.33. You're getting it. This is the correct value. So this we got under the assumption 2 kg, 3 kg slipped. So when you took 2 and 3 were going together, the time was giving 20. So that means for T greater than 70 by 3, 3 kg and 5 kg also slip. Then, yeah, you have to draw the free body diagram for this. This section will be F2 max, which is 10. This is F1 max, which is 2. And this is the acceleration. So it will be 10 minus 2, 8 by 3. Five kg F is equal to 2, and this is F2 max is equal to 10. this acceleration will be t minus 10 by 5. Now if I try to plot a graph, for 10 seconds, everyone is going together. This becomes constant. This is the 2 kg block. Then they'll go together, and this is the 3 kg block. This is the 5 kg block. The graph will keep splitting. Let this angle be alpha, let this angle be beta, let this angle be gamma. This was 10 seconds. This was 70 by 3. Tan alpha was 1 by 10. That was the initial slope. Acceleration was t by 10. Then the acceleration was t by 8. So tan beta was 1 by 8. Then the acceleration tan gamma was 1 by 5. Are you guys able to see the graph? So it will split. So all three will go together. Then 3 and 5 will go together. And then 5 will separate off. So every time the friction reaches max, it spikes up. This is how you handle 3 kg, 3 body problems. Yeah, they're a little lengthy, but that's the process. All clear with this? So first you have to get for both of them and see. We'll do one more like this after the break. So take a break, come back by 9:40. We'll continue from here. Any doubt so far? Chalo, come back in 5 minutes. Same thing. Yeah, switch on your cameras, everyone. I'll just change one thing here. We're keeping the force at the middle block now. Hmm. Let's get this, everyone. Cams on, everyone. Let's start off. There, give it a try. This is for the three blocks. This time I kept the force in the middle block. Same process. Get this. If you got this, you know how to do three block problems. Try. I'll give you 4 5 minutes. Everyone should draw. Everyone should try. Yeah. 'Everyone should try. 10 seconds. Yeah. Get the whole graph. 18 seconds. They move separately. Okay. I'll give another minute, then I'll show you. Okay, let's see. So step one, assume all are going together. And then we get acceleration is equal to t by 10. This is the same story. Take the 2 kg block. This is F1, this is acceleration. Yeah, this thing is same thing, 2a less than equal to 0.1 into 20. So this is t by 5 is less than equal to 2. So t is less than equal to 10 seconds. So again, F1 is saying the same thing. F1 is saying, boss, up to 10 seconds, I can keep this together. Take the 5 kg. Again, but remember, F1 does not know what is F2 doing. This is F2 and this is acceleration. We get F2 is equal to 5a, which is less than equal to 0.2 into 50. Yeah, I think we got the same numbers, luckily. So this guy is right and this guy is wrong. So till here, the story is the same. So for 10 seconds, all are going together. For t greater than 10, they're going to slip. For t greater than 10, this F1 becomes maximum, which is a 2, and this acceleration becomes 2. So for t greater than 10, we'll again assume the 3 and 5 kgs are going together. Yeah, so far everything is looking identical. This is F1 max, which is 2, and this guy is F is equal to t. This will be t minus 2 is equal to 8a. Yeah, this also is looking same. Take 5 kg there, and this time it will take F2. F2 is equal to 5a. This is less than equal to, how much was this? 10 newtons. So t minus 2 by 8 is less than equal to 2. So we get t is less than equal to 8 to 16, 24 seconds. Wait. Did I goof up something? T minus 2 is equal to 8a. This is t minus 2. 16, 18 seconds. Yeah, this thing changed. Did you see? Previously, when we did that, we got 23.33. 70 by 3 we got. That number change. No, so the change happened here. This thing slipped at 18 seconds only. So for t greater than 18, everyone slips. So I didn't change anything. If you see the same brute force, like we just did same step by step, the numbers adjusted everything accordingly. And then at this point, everyone is slipping. There. When you plot the graph, for 10 seconds, everyone is going together. Then the 2 kg becomes constant. At 18 seconds, this becomes constant. This is the 5 kg. This is the 3 kg. You can get the slopes. All clear with the process? This will be tan inverse 1 by 3. In the previous problem, that was tan inverse 1 by 5. Check. That's how you do it. Any doubts on this? That's your 2-block and 3-block problems. With that, we're done with friction. If you see friction as such, harsh look.
So can you just go to the previous page for one?
Previous page here.
Yes.
Yeah. So there, if you see red friction chapter, it had a lot of matlab what it is literally NLM. The only thing is finding the direction of friction and the magnitude. It is not over, like I said. Now, whatever you learned in NLM friction will come in circular motion. So these things, right, will always keep piling up one after another. So the next chapter is circular motion. We'll do a little introduction today. Again, in this chapter, right, primarily there is only one thing. There is something called a centripetal acceleration and centrifugal force. We'll talk about other things, but these are the two major things. If you know how to find it, that's it. So the story will remain same. Choose your system, draw the free body diagram, assign accelerations, write, resolve the forces and accelerations, and solve. So the only extra thing you will learn is centripetal force and centrifugal force stuff. But before that, we will also study other things also in this. So chapter can be little confusing because of that. But don't worry, we will do it step by step. Circular kinematics. So the first thing, so whenever you study something is going in circular motion, we used to study position. Here we will study something called angular position, theta. Again, it has same similarities with your regular kinematics. There everything was linear, here everything is angles. So this is an angle made by position vector with respect to a reference. So if you choose this line as a reference, it is your choice. You can take any line as a reference. Generally, we take x-axis. And let's say if a body is going in some random curve, this is your position vector r bar. This is your angle theta. So this is another common misconcept. Huh? People think it should be always a circle, not necessary. Angular position doesn't care whether r is constant or not. Yeah, the special case is when you go in a circle. So angular position is simply the angle made by the reference, by the position vector with respect to the reference. If this is your position vector, then this is your angular position. So for angular displacement, magnitude of r bar, we are not interested. Magnitude of r bar is not needed. Yeah, that's our definition. How much angle are you making with respect to reference line? Straightforward. Then we define angular position, angular displacement. If you see, they kind of look like kinematics, but everywhere I'm just putting the word angular. So delta theta bar is given by theta final bar minus theta initial bar. So even thetas have directions. If you remember the pseudo vector, if a vector is rotating clockwise, we use right hand thumb rule. Remember that screw K example? We take it as minus k into the plane. If you're rotating opposite to the clock, we call it anti-clockwise. The direction is plus k cap. This is out of the plane. We have done this in detail in vectors, if you remember, pseudo vector and all that stuff. I'll show you anyways. So there here. So basically this thing gives you the rotation ka direction, the fingers. The thumb gives you the direction of the vector. Yeah. We have done this in vectors. Sure. Pseudo or actual vectors, page 78. Now, in case you forgot about this, look into my screen. If this is the bottle, right, and you want the cap to come out, so take your right hand, so put your thumb out. So you want the bottle to cap to come out this way. So these fingers will tell you the direction. So if I rotate the cap this way, the cap is going to come out. If you want the cap to go inside, put your thumb down. This is the rotation. So I need to rotate the cap this way and the cap goes inside. Do you guys remember this? That was the right hand screw. So even though the rotation is happening in the plane, the direction is going up and down. So that is the meaning of it. So the curl of the fingers gives the rotation and the thumb gives you the direction. Clear with this? So just to give an example, so let's say this was the reference. So let's say the particle was initially here. So this is theta1, which is pi by 3. And let's say this was theta2, which was pi by 6. So if someone asks you what is theta1, you will write it as pi by 3. It is going anti-clockwise, k cap. This is how you represent it. So from the reference line, you have to rotate it anti-clockwise. If they ask you what is theta2, you will say pi by 6 minus k cap. So you are defining a direction even for the vector. So this is clockwise for the angles. So if they ask you find delta theta, then you have to subtract it with a vector. And I hope you remember pi radians is 180 degrees. That was the whole story there. All clear with this? So all these are pseudo vectors. The angular displacement, angular velocity, all this stuff is, these are pseudo vectors. Then we define something called angular velocity. The symbol is omega bar. Simply, remember what is velocity? Rate of change of position vector, rate of change of angular position. So angular velocity omega bar is given by d theta by dt. If you want average angular velocity, then you take delta theta by delta t. You can also get delta theta by integrating omega dt. This kind of looks like displacement is integral v dt. This is nothing but area under omega t graph. They look exactly same as kinematics. You just added angular everywhere. Means if someone takes a omega versus time graph, This is the positive area. This is the negative area. So that means we also have something called angular acceleration. You'll see that later on. So if you have a graph like this, so the slope will give you d theta by dt. So in a theta time graph, slope is nothing but angular velocity. All clear so far? Now, if I relate this to your regular velocities, we'll take a simple case when you're going in a circle. We will talk about this in more detail actually. What if you're not going in a circle? We have a full study about that, which is not there for mains. Even in advanced, it is not there. But if they at all, but they have a habit of asking. They always give it as a paragraph and then they ask. So we are going to study that stuff also, which is not there in the portion. I think last time they did was 2017 or 16, man. They gave a full paragraph on it. They explained something called Coriolis force and all that stuff, and which is not there in the portion, but the expected you will know that and solve. So we will do all that stuff also. So this was R bar, this was theta, this was your V tangential. This length will be your arc length S, which is R theta. So we have S is equal to R theta, differential with respect to time. That will become ds by dt is equal to r into d theta by dt. Here r is constant, so we are not going to mess with it for now. And this becomes v, this becomes r into omega. So this v is what? This is the tangential velocity, because the s is the tangential distance. When you differential, you get tangential speed. This is the vector form, everyone. So v tangential is given by omega bar cross r bar. That is a cross product. This is the relation between tangential velocity and omega. This is not the full velocity, only the tangential velocity. There, that's a bit about it. So let's see a few questions on this. So there, I just taught you 2 to 3 things. Theta, so delta theta, omega is d theta by dt. So we're just going to play with this one equation for today. And this idea, V tangential is R omega. All clear with this so far? Let's see a question. We have done few of these things before, but let's see. So we have your y and x axis. We have a particle here at 0, d. This particle is going in a straight line with speed u. The observer is standing at the origin. So this guy is looking at the particle and this is going horizontally with speed v. I'll do one thing, let's call it 0, h. Particle moves parallel to x-axis at a height. And this guy is looking at the particle. Now see, this is what I was saying. People think, in order to define omega, you should go in a circle. Not necessary. When the particle is going, just look at this guy. He's looking at this, he's looking at this, he's looking at this. If you observe, this angle is continuously changing. You're getting it? So there is no need for something to go in a circle. Even something which is going in a straight line can feel like it is going the angle is changing. Meaning, just try to observe yourself. Just look straight. Okay, look straight. Don't turn your head. Using only your eyeballs, try to look left. And then rotate your eyeballs towards the right. So, you know what you did? The line joining from your eyes to the wall, that line is rotating, isn't it? When you rotate your eyeballs, that's actually angular velocity. That line is actually rotating. So if you imagine a line, an imaginary one coming from your eyes to the front of you, and when you turn your eyeballs, you're actually rotating that line. You're getting it. So what you're looking at is angular velocity. I'll give you a simpler example. See, think of like this. Did you ever notice this when you're going in a car or a bike or a train, right? When you look at the road, it feels like it is going fast. But tell me one thing. Let's say if you're going on a road with a speed of 50 kilometers per hour. Now, if you have a tree here, let's call it A, and if you have a tree here, let's call it B. By relative velocity, you should think both the trees are going with 50 and 50. Technically, they are going with the same speed. But then why do you think A is going faster than B? कभी observe किया? The thing which is closer, it feels it is going faster than B. Because what happens in some time when it goes this thing, they are traveling same distance, agreed. But look at the angle here. This is covering this much angle. This is covering this much angle. Did you see the difference? The one who is very far, they cover a smaller angle compared to the guy who is very close. And you think this A is going faster than B, even though they're traveling same distance. We humans are not capable of seeing lengths. Whatever you see is always angles. In your life, you have never seen length. You have always seen an angle. Tell me one thing, which is bigger, your finger or the computer monitor in front of you? Monitor, right? Put your finger in front of the eye. It looks much bigger than the building also in front of your house. Because when you put the finger so close, it subtends a very big angle. The finger looks much bigger than anything in front of you. Try to look at your nose. You can't look at it. It will go out of focus. Your nose looks like a big frog there, isn't it? So actually, your eyes are always looking at your nose. Your brain ignores it. It is always in your sight. And don't try to focus on your nose. You get a headache. And there's something called distance of least vision. Your eyes cannot see something below a certain distance. But anyway, so that is the thing. So you need not go in a circle to define angular velocity. So be careful with that. So find angular displacement and angular velocity at time t, as seen by this guy. This also depends on who is looking at you. Depending on where you're standing, people say different things. Find angular displacement and angular velocity as seen by the observer at the origin. Let's see how will you handle this. Again, what is angular displacement at this theta? What is angular velocity? Rate of d theta by dt. Let's see how will you do this. And the best part, you already know this. Think, give it a try. Whatever you think. Don't worry about right and wrong answer. No, whatever it is. Right, Ahna. That is fine. Now, how do you differentiate that? Get the angular velocity at time t. Okay, let's see. I don't know whether you realized we did this before, but okay, I'll show you that also. So after time t, you must have traveled somewhere here. This will be v into t. So now your vector has become like this. So this was your r bar. This was theta, and this was the height h. So yeah, it's pretty straightforward. Tan theta is equal to vt by h. So you want theta, so that's your angular position, tan inverse vt by h. You want angular velocity, we need d theta by dt. So differentiate this. Differentiate with respect to time. So if you differentiate tan theta, we get sec square theta, d theta by dt there. That's your omega. And this will become v by h. So d theta by dt is equal to v by h sec square theta. And sec square theta is nothing but v by h into 1 plus tan square theta. And tan theta is nothing but vt by h. So that is v by h plus 1 plus v square t square by h square. That would be v into h by h square plus v square t square. This is your omega, everyone. Make sense? There's a much faster way to do this. As this particle is going here, this speed will be v. This was your r bar. This was theta, right? So this is 90 minus theta. So if you resolve the velocities into components, this will be v cos theta, and this will be v sin theta. So the question comes, who is responsible for changing the angle? This is your v tangential. This is responsible for changing the direction. So omega d theta by dt, that's the rate of change of angular velocity, is nothing but v sin theta by r. And we know this height is h and this is r. So we get cos theta is equal to h by r. So r is equal to h by cos theta. I think I wrote it wrong. Wait, this is v sin theta. This is v cos theta. So this is nothing but v cos theta by r is nothing but h by cos theta. So we get omega is equal to v by h sec square theta. Can you see the same answer? And do you guys remember where we did this? कुछ तो याद आया? Remember this question? dr by dt, rate of change of vector. There, if you remember the same story, look at this, what I said. This is what we did there. We said this u cos theta was responsible for changing the magnitude of vector. So this was d mod r by dt. It's called radial velocity. U sin theta was tangential velocity. Remember this now? So there were two components. One guy was changing your magnitude and one guy was changing your direction. So we ignored that thing, the direction one there, but now we are going to use it. So page 48, kinematics. So you should definitely refer that once. So if you, this way, right, you can avoid calculus. So the two components had two different rules. One guy was d mod r by dt and one guy was d theta by dt. Clear? Let's see one more. We have a particle going in a circle. This is a standard question. Particle goes in a circle with speed u. The radius is r. So O is the center. So we have one person standing here. A is a point on a circumference, another guy is standing here. So these two people are looking at it. The particle is somewhere here, which is going to. So in the previous question, right, for example, C, in the previous question, if you had an observer standing here, what will he think? He will think the line is always going straight, right? Will he ever think the angle changed? So for him, theta is 0, angular velocity is 0. So did you see, depending on who is watching the problem, the answer will change. So angular velocity, right, depending on who sees it, it can be different. So O is the center and A is the point on a circumference. Find the angular velocity as seen by A and B, two different questions. The particle doesn't care. Particle is simply going in a circle. So this is one important thing. Like that's what I said. Doesn't mean every time it has to go in a circle. Find omega as seen by O and A, two different questions. Give it a try. This is a standard question. Like it has come multiple times, so easy one. So CET bits type of question. Let's see. So look at this. First, let's ask O, okay, boss, what are you seeing? So if you ask O will say, this is the angle theta that I'm observing. So every time this particle is going in a circle, what is changing is this theta. So fair enough. And we can clearly see here, this is perpendicular. So angular velocity as seen by O is nothing but U by R. That's your V tangential. By R, which is U by R, which is nothing but d theta by dt. Perfect. But if you ask A, we have an issue now. He will say, oh, this is the line that I'm looking at, right? And the problem is, this is the angle I'm looking at, V alpha. And if you see, this is not 90 degrees. So if I try to take the components, which I can do, I should take this Yuka component this way, and then you take this length and do it. It becomes really complicated. But if you ask A, he will say, my angular velocity is d alpha by dt. Now in this triangle, we can do a little geometry. It's much faster than actually trying to find V tangential. If this is alpha, we can clearly see this is radius r. This is also radius r. This is an isosceles triangle. So this is also alpha. If this is theta, this is 180 minus theta. So the sum of the angles 2 alpha plus 180 minus theta must be equal to 180. So we get alpha is theta by 2. So if I differentiate this, d alpha by dt is half of d theta by dt. So So angular velocity as seen by A is half of u by r, which is half of angular velocity of O. So the person A will think this particle is going slower. Half of it is going with what? Half of the angular speed as O. This is a much better way to do, like using directly the angles. But if you want to do it the V tangential story, then yeah, we can do it. You have to put little effort. This is A. This is the point there. So this would be U. This is alpha. This is alpha. Then this angle will be 90 minus alpha. Then we have to resolve components. So this component will be U cos 90 minus alpha, and this component will be U cos alpha. This will be U sin alpha. So U cos alpha, this is your V tangential. If this is R and this is R, we can drop a perpendicular. This will be R cos alpha and R cos alpha. So we get omega of A is V tangential by the rate distance, which is V cos alpha, and the distance will be 2R cos alpha. Cos alpha will cancel, you get U by 2R. Got the same? That story always works. But yeah, you have to do a little work. But if you see this is more easy. Every time O thinks angle is theta, A will think angle is theta by 2. It is understood. This guy will see half of the angular velocity. And did you see the same particle when two people are seeing, they think the angular velocity is different? So omega depends on who is seeing it, from where. So unlike a regular speed, omega is different. It depends on the observer. All clear with this? Let's see one last one. So we have a rod here. This is hinged here. So this rod is fixed on the left side. It cannot move. So here we have a hemisphere. And someone is dragging this hemisphere with a constant speed u. If you drag this hemisphere, this angle theta will change. Meaning this is how the picture will look like. Initially, the rod will be like this. After some time, when the hemisphere has gone till here, the rod will become like this. So you can clearly see the angle is decreasing. Initially, it is more steep. This is what happens. The rod is continuously moving. So that means if you pull the hemisphere, the rod is going to change. So find omega of the rod when theta is 60 degrees. So when this angle becomes 60 degrees, what is the omega of the rod? Meaning if I have to give angles example, let's say this angle is initially some 75 degrees. Now this angle is something like 30 degrees and so on. So when you're pulling, the angle is changing. So the rod will think I'm rotating. Let's see how we'll do this. Find the angular velocity of the rod as function of theta when theta is 60 degrees. So the whole game is that you have to somehow get that theta and differentiate it. That's you get the angular velocities. Let's see any answers. So the thing is, when the rod is moving, what is changing? The horizontal distance is changing. So you need to create variables. That's the headache with this. So let the distance between the hinge, so let's take the hinge as origin because that guy is not moving. And this distance is x. And since the rod is lying on this, if you realize this actually forms a tangent, the rod actually becomes a tangent because it is just grazing on this. This is r. Yeah, these are the two variables. So first you need to figure out the rod is a tangent and let this distance be x. So whenever the hemisphere moves, x is increasing. Perfect. We need to get theta. So sine theta will be opposite side r by hypotenuse x. So that's your triangle. You're done basically. Differentiate this. Sine ka differential cos theta d theta by dt. R 1 by x ka differential is minus 1 by x square dx by dt. Chain rule everyone. X power minus 1 ka differential. This is cos theta d theta by dt. That is your omega which you want. Is minus r by x square and dx by dt is nothing but u. So as you're going to the right, that is your speed. Perfect. And what is x? X is r by sine theta. So this is cos theta into omega is minus ur by x square is r square by sine square theta, which goes up. So we get omega is equal to minus u by r sine square theta by cos theta. The minus indicates theta is decreasing, which is true. There, you got your answers. Put theta is equal to 60 degrees and you'll get your answer. Are you clear what we're doing? So you need to get the theta in terms of horizontal distance and then you're done. So when you say angular velocity, right, don't always think it has to go in a circle. Things can go whatever they want. They can do whatever they want. Is the angle changing or not? That is the only question you need to ask. All clear with this? That's a bit about circular motion. So when we catch up on next class, Monday, we will continue from here. We'll do more on this. So this first part is called circular kinematics. It looks like kinematics only, velocity, acceleration, all that stuff. The second part is circular dynamics. That looks like NLM, friction, and all that stuff. Again, the chapter, right, almost 80% will look like NLM and friction, 20% is new. So be thorough with your NLM and friction. Friction, I think I sent you a sheet. I'll see if I send you again. But do start solving. If you have not done anything before, I would strongly suggest do HCV, do my booklet or your classes ka booklet. Start doing it. You need to solve at least 100, 125 questions per week for a topic. If you don't do at least that much, you will never improve. Right? So do start doing. But if you have already done your booklet and all, maybe you can try the sheet or you can try something else. So I'll send you something in the group though. So okay, with that we'll wrap up for the day. So any doubts, anything else, please stay back and ask. And do remember there's a test on Friday, so make sure to give it. So I'll see you on Monday.